The 3D scanner takes any given part that you can sit down on a table, and it scans it into a computer with the exact dimensions that the part has. It literally scans in 3 dimensions by triangulation of a laser beam. Bounces a laser beam off the part onto a reflective dot and feeds it back into the scanner, and the scanner tracks that dot's position and is able to build a three-dimensional model in the computer. You can scan anything basically under a cubic meter. The volume that the scanner can take in is limited to a cubic meter, mostly because of the limitations of the computer itself. So anything under a cubic meter, which a cubic meter is a big object, regardless of what it is, it's a fairly sizable object. There's 2 different methods to scanning. There's it's called surface feature scanning, which is a dot board, and you place the part on the board, and for that they have to be relatively small. Anything that you could hold in your hands basically is as big as you can get it for that. And then you have surface scans, straight surface scans, which you actually place the dots on the object, and that's what you can get up to a meter. And those run, anything from a foot tall all the way up to the cubic meter or cubic yard measure. I've been working for Campus Ventures since the middle of February. Between the software and the scanner itself, I have about 50 hours. I just completed my first project, which was the chrome parts. We are currently working on a dome for a carrying case for Texas Instruments that carries the silicone wafers between workstations. Some other parts have been other car parts. Car parts seem to be a very big or popular item because of their complex shape. The first step is making the object something the scanner can read. The scanner cannot pick up reflective objects and non-reflective objects. So it's your job as the engineer to find a happy medium for that. That's the first step, and then you have to get the part obviously coated, and then depending on the size of the part, either cover it in the reflective dots or put it on the dot board. For the chrome parts that we did, they were small enough, we were able to put them on the dot board, and from there it's just a matter of holding the scanner over it and pulling the trigger. Of course, that being said, it can take sometimes 10 or even 20 scans to get a part to your satisfaction because of the nature of 3-dimensional objects. The scanner doesn't like every nook and cranny or curve even of the part, and it's hard to pick up sometimes, so you do have to do multiple scans of whatever you're doing, regardless of the part. I'm excited to learn the new software because now that we've got all this stuff scanned in, it's time for me to get on to the editing software so we can join the separate scans and manipulate the parts so that we can send them off to the CAD modeling software. There's many steps in the process. You have to get it scanned into the scanner software, then you have to finish it in the scanner software, then send it off to the editing software so you can join scans, and then you have to send it off to your modeling software. So it is quite the involved process, but it's very, very fun. The average project, again, depends on the finish of the part, the complexity of the shape, but it can take anywhere from just a couple hours up to a month. Going back to the chrome car parts that we recently did, the prep time alone to mat the surface of the part was 2 hours per mat. Of course, every part you do needs at least 2 scans, one for the top and one for the bottom when you're setting it on the board. Or irregardless, if you're setting it on the board or have dots on it, you have to turn it. So to prep for 2 hours, and a good quality scan can easily take an hour. Bigger parts generally will take longer, obviously, because of their size. More complex parts, things with a lot of curves and surface features will always take longer. After that, it's just a matter of processing through the software, and depending on the quality of your scans, it can take a full day, again, up to a week. I believe they're billing out for our labor somewhere around $40 an hour, but I could be wrong on that. It's every bit worth it. even if it is at $40 an hour, because this stuff saves, rather than paying an engineer $35 or $40 an hour for a week to sit in front of a computer modeling things, you can pay not necessarily an engineer, someone beneath an engineer, half that or even a quarter of that to scan this part in for a couple hours. You can have alternative methods like 3D CAD modeling, but the 3D scanning picks up every single surface feature of the part in real size. So you don't have to deal with sizing up or sizing down the part at all. It picks up the features, where they are on the part, and the exact size of it. So it's more accurate, especially for more complicated parts that have a lot of curves or a lot of small features, whether it be nubs sticking out or a lot of a funny shape, anything with a funny shape. It will pick up those features more accurately than what you could do in the same amount of time through a CAD modeling software. Of course, you could sit down and measure the part with a pair of calipers, but depending on the complexity of the part, it can take magnitudes longer than it would to just scan the part in. And that's typically what we do stuff for, is companies that either don't want to or can't afford to pay a staffed engineer. They come into Greg and talk to him, and we basically do their R&D work for them at maybe 1/10 of the price. My favorite part is seeing the results of your scan. Sometimes it's a little bit disappointing when you get objects that are really hard to scan, but it is extremely gratifying when you have a small complex shape sitting on the board and you manage to get it all scanned in. Maybe it took you an hour, maybe it took you 2 hours, but at the end of the day, when you close out of the program, you have a satisfactory three-dimensional model, digitized model of what you just had sitting on your board.